Zoom meet or accepting only the 100 participants. Now they restricted. So for today afternoon session, we are having a resource person from NIT Trichy, Dr. E.Sivasankar, Assistant Professor, CSE Department, NIT Trichy. So, sir currently working as the Assistant Professor in National Institute of Technology, NIT, and already he worked as a Senior Lecturer in MEPCO Length Engineering College and Raja Engineering College, Madurai. So, he completed his PhD in Manomaniyam Sundarnar Universities and MTech in Manomaniyam Sundarnar University. So, sir already got lot of fund from the government institution to conduct various workshop and for projects. So, I welcome you, sir. Uh, so, now I hand over the session to sir. Sir, you can start.
Okay, madam. Thank you, madam. Thank you for your nice introduction. Right. So
Thank
let me teach you about intelligent agents in today's class. Right. So in artificial intelligence, we have these agents, intelligent agents. So agent is anything that can perceive its environment through sensors and act upon the environment through actuators. Right. So agent, the major components are going to be sensors and actuators. So it can sense the environment through sensors and it can act on the environment through actuators. Right. So if you look into the components of the sensor, like if you look into the components of the agents, the major components are going to be sensors, actuators, and effectors. Right. So sensors are basically used to collect information from the environment. Right. If there is any change in the environment, it can be detected by using sensors. And actuators are the components that convert energy into motion. Right. So whenever an action has to be carried out, an action has to be performed, it is carried out by actuators. And effectors are the device which affect the environment. Right. So these are the major components of any agent. Sensors to sense the environment, actuators to convert into actions, to convert energy into motion or actions, and effectors are the components that affect the environment. Right. So we'll study the different types of agents. An agent can be a human agent, like as a human agent, our sensors are going to be eyes, ears, nose, right? So we have sensors to sense the environment, and actuators, like the actions are done by hands, legs, right? They are used to carry out the actions, and similar to human agent, we can also have a robotic agent where the input can be an input image through some cameras, or it can get some input direction through infrared range finder, NLP, right? So natural language processing, right? Like in the case of chatbot, you can give some input in the form of text input. You can give some input in the form of an voice input, right? So they are all used for sensors, and we use various motors for actuators, right? So the action is carried out by using various motors. And similarly, if you look at a software as an agent, right? So the input is going to be the contents of your file. The contents of the file can be given as an input, and similarly sensor inputs, right? So you have some IoT devices or something, real time you are going to collect some data, and the sensor can be used as an input for software agents. And these agents, they act upon the input and display the output on the screen, right? So these are some examples of software agents, right? So agent can be a human agent, or it can be a robotic agent, or it can be a software agent, right? So now we'll define what do you mean by a rational agent, and how to define how to define agents in artificial intelligence. Right? So an agent perceives the environment and act upon that environment to achieve some task. Right? So it has some perceptions and actuators. It perceives the environment and act upon the environment to achieve some task. Right? And agents function from perceptions to actions. Right? So perception to actions. An agent converts perceptions into actions. And when we talk about rational agents, right, so we would like to build rational agents where we have to improve the performance measure of the agents. And artificial intelligence aim to design the best agents that have high performance measure, even the computational limitations, right? And agent can be agent can be a software program that can be integrated into a hardware, right? So agent is given as a architecture plus program, where it's going to be a software program that can be integrated into some hardware available. So this is how we define rational agents to improve the performance metrics of any system. We can go for designing a rational agent. We can embed an agent, which is a software program, into some hardware. Put together, we have agent, right? So once you know what is agent, like it gets the input from the environment and it acts on the input. It converts the perceptions into actions. We'll be interested in environments in artificial intelligence, right? So basically, whenever we talk about agent, we talk about PEAS, right? So any system, we talk about performance metrics, environment, sensors, and actuators, right? So any agent, you are expected to define PEAS, which means that performance metrics, environment, actuators, and sensors. Right. So let us see what is the PAS values for a driverless car. Right. PAS value for a vacuum engine. So, for example, for an automated taxi or a self-driving car. So what is the performance metric? So the performance metric is going to be safety. So safety, time, right? We have to reach the destination within a specific time, legal drive, and comfort, right? So the driverless car or autonomous vehicles, they should give you comfort. It should be safety for someone to travel in that particular car, right? And what should be able to reach a particular place within a specific time, right? Within a time constraint, and it should follow the rules of driving, legal rules, road safety rules while driving. So these are the performance metrics associated with autonomous vehicles. And the environment is like where you are going to drive the autonomous vehicles, right? So the environment is going to be roads on which you are going to drive the autonomous vehicles, other vehicles that are there in the road, pedestrians, and road signage, road sign, right? And regarding the sensors are going to be, they give input to the agent, right? So in this case, for autonomous vehicles, the input is given by means of cameras, GPS. We have speedometer to control the speed or to identify the speed, odometer, accelerometer. We have engine sensors and keyboard, right? So these are the sensors that can be used to control the speed of the vehicle, right? To identify the location where we are expected to reach. And we have various actuators like actions, like you'll be able to apply a brake, you can apply a horn, right? So you can use an accelerator, steering in your car. And while autonomous vehicle is traveling, it needs to apply a brake, it needs to apply a horn, and so on. So these are the various PEAS metrics for a autonomous vehicle or a self-driving car, right? So similarly, whenever we are going to design any agent, you are expected to know the PAS values, right? So for example, let us take another example. Let us look into our ATM system, right? So ATM system used by banks. So what are the performance metrics associated with the ATM machine, automatic teller machines used by banks? So whenever I perform some transaction, I want it to be reliable, right? It should be secured, right? Others cannot use my account. It should be secured. It should be reliable, and it should provide some fast service. Like I need to make the transactions within a fraction of seconds. And if you consider the environmental variables for ATM machine, right? So the environmental variables are like the human system, customers alone, or the environmental factors associated with an ATM machine, and sensors, right? How do you feed some input into a ATM machine, right? I will use some touch screens or keyboard. You have some simple keyboards with simple alphanumeric values, whereby you can feed some input, or you can use mostly they use touch screens. And actions, actuators. What are the actuators available in a ATM machine? So it will display our balance in a particular account. You'll be able to perform some transactions, right? You'll be able to either deposit or withdraw from your ATM, right? And it also performs some validity checks before completing the transactions, right? So given any system, any agent, you are expected to know the performance metrics, environment, actuators, and sensors that are associated with a particular system, right? So let us look into the next example. So the next example is like a vacuum cleaner. Again, we have a robot based vacuum cleaner, right? So the performance of any vacuum cleaner is measured by its cleanliness efficiency, right? Which is the distance traveled to clean, the battery life of the particular cleaner, and security, right? So performance for any backup cleaner is like how well it can clean a particular floor or a carpet, right? So it's like cleanliness efficiency, like it is defined like how much distance it can clear in a particular floor or a carpet, and battery life, right? So if you look into the various environmental factors associated with the vacuum cleaner, again the various environmental factors available in a vacuum cleaner are like you have a carpet area where we can use it, where it can clean nicely, can work on your wood floor, table, room, and different obstacles or the environmental variables associated with a vacuum cleaner. And again, if you look into the sensors, so sensors, like any most of the agents, the input is like a camera to capture input. It can also have some sensors like dot detection sensors and infrared wall detection sensors, right, to identify any obstacles on the particular floor area or carpet area. We can go for infrared based wall sensors. And for cleaning the dirty area, you need to have some dot detection sensors. And finally, the actuators. So the action is carried out by different brushes available and carried out by the vacuum extractor and wheels of your vacuum cleaner. So it moves through its wheel to extract the dirtiness from your floor using the different brushes and vacuum extractor, right? So you are expected to know the performance environmental values, actuators, and sensors for any intelligent agent. So let us have one more example, like for example, e-commerce system. Right? So like everyone is likely to buy some books online, right? So what are the PAS parameters for an e-commerce system? Right. So again, the performance metrics are going to be, I need to perform some secure, reliable business processing. Right. So my transaction should be secure. So right. So and it should be reliable. So I should be able to buy the product or service that is provided by the e-commerce system. And secure means like it authenticates like my details, and only like I'll be able to purchase using my account, right? So it's going to be it should be reliable as well as it should be secure. And if you look into the environment of the e-commerce system, it contains like details about lot of vendors who are listed in the particular system. It contains details about the products and different vendors who are associated with the product, and sensors. Again, in an e-commerce system, whenever you buy something, the input is by means of some keyboard or by mouse, right? And the actuators are going to be the products will be displayed with some price tag, whereby you'll be able to buy your product or your service from your e-commerce system, right? So this is how we define this PEAS values for an agent, right? So next, we'll look into the different environments in AI. So basically, in artificial intelligence, we have different types of environment in which the agent is being deployed. So one is like the first type of environment is like a fully observable versus partially observable environment, right? So if an agent sensor can sense or access the complete state of an environment at a point of time, then it is called as fully observable agent. Else it's called a partially observable agent, right? So agent environment can be either fully observable or it can be partially observable, right? So if an agent can have details about the complete state of environment at any point of time, then it is said to be fully observable environment. Else it's going to be partially observable environment. And similarly, we can also have an agent with no sensors. Then such an environment is called unobservable environment, right? So fully accessible environment means an software agent is given access to all the input that is present in the environment at each point of time. We call it as a fully observable environment. Whereas if it is not given access to that state of environment at a particular time, then it is known as unobservable environment, right? And that can also be partially observable environments where we have only few sensors to collect data about the environment, right? So the next category is like deterministic versus stochastic environment, right? So if an agent's current state and selected action can completely determine the next state, we call it as deterministic environment, right? So we have some current state and we are going to perform some action in the current state that can determine the next state of the environment. It is called as deterministic environment. Whereas a stochastic environment is purely random in nature and it cannot be determined by an agent. And the next category in agent environment is going to be whether an environment is going to be episodic or it's going to be sequential, right? So in the case of episodic environment, we have atomic actions or there is a series of one-shot actions, and only current percept is required for the actions. Right? So episodic environment means we have only one-shot actions and only current percept is required for the actions. Whereas in the case of sequential environment, an agent requires memory as well as past actions to determine the future actions, right? So sequential actions, you have the history of the previous actions that are being carried out stored in the memory. So requires memory of past actions to determine the next best actions. And if you look into the agent, again you have a single agent versus multi-agent environment, right? So if only one agent is involved in an environment and operating by itself, then such an environment is called a single agent environment, right? So whereas if there are multiple agents for operating in an environment, we call it as multi-agent environment, right? So while you design some gates, in the case of multi-agent environments, we can have like agents that are competitive in nature, right? You want to build a chess software agent for playing chess, right? So then you need to have multi-agents to work in a competitive environment. Similarly, you also can have some cooperating multi-agents where multiple agents will work together to carry out a particular task. And the next category is like static versus dynamic. So if the environment can change itself when the agent is deliberating on an action, then such environment is called dynamic environment, right? So the environment is continuously changing, like an autonomous vehicles, like driving a car. A software agent is using driving a autonomous vehicle where the environment, the road or the pedestrian, like other vehicles that are present in the environment is continuously changing dynamically, then it is called a dynamic environment. Whereas if the environment for a particular software agent does not change dynamically, then it is called a static environment. Right? So for example, you have an agent for solving some puzzles. So the crossword puzzle is solved, then it's an example for a static environment because the problems are the same, right? The problems and the environment is same, then it's known as static environment. And it's easy to deal with a static environment compared to a dynamic environment. Right? So in the case of dynamic environment, a software agent needs to keep looking at the world at each and every action. Right? So he needs to observe others, observe like you have a dynamic environment, you need to observe your competitors, you need to observe your peer group before performing any actions. Whereas in the case of static environment, the environment is going to be static in nature. And finally, like agent environment can be either discrete or continuous. So discrete means there are finite number of percepts and actions that can be performed. Right? So we can have some finite sequence of actions that can be performed. Then it's known as discrete. Else it's called as continuous environment. Right? So for example, playing a game like chess is a discrete environment, as there is a finite number of moves that can be performed by a software agent. Whereas self-driving car is an example for a continuous environment, right? So these are the different categories of agent environment in artificial intelligence. And next we'll study about the different types of agents available, right? So the first basic software agent that is available is known as simple reflex agent. So reflex agent, takes decision on the basis of the current percept and they ignore the percept history. So basically they don't have state element to store the percept history. So they don't have any memory to store the previous percept sequences or percept history. So they are expected to take actions based on only current percept and they ignore the percept history. And simple reflex agents, they can succeed only in fully observable environment, right? Since they don't have any memory, they can succeed only in fully observable environment. So they do not consider the percept history during their decision and action process, right? So since they don't have any internal state, they will not consider any part of the percept history during their decision and action making process. A simple reflex agent, it works on the basis of condition action rule. So it senses the current state and it maps the current state to action, right? Such as a room cleaner agent, it works only if there is a dirt in the room, right? So it's going to be condition action rule based. So if something is true, then things will be done. If the condition is false, then the action will not be carried out, right? So it's like a simple if else statement. If the room is dirty, the agent is expected to clean the room, else it is expected to be stationary, right? So the simple reflex agent, they work on only the current percept and they do not have any state element to store the percept history. So the actions will be based on only the current perception, right? So they can perform only, they can be given access to the complete observation about all the environment, right? So it can work only in a fully observable environment. And a simple reflex agent, it works on this condition action rule, which maps a state, which means that it maps the current state into action. So the problem in this simple reflex agent design approach is that it has very limited intelligence, right? So since they don't have any percept history, it's not possible to store the history of the data that is being perceived. So the thing is that they have very limited intelligence and they do not have knowledge of non-perceptual parts of the current state, right? So the percept history is missing, so that they do not have any knowledge about the particular system, and they are very big to generate and store, right? So since you need to give complete access to the environment at each and every time, it's very difficult to generate simple reflex agent and to store them, and it's not adaptive to changes in the environment, right? So simple reflex agents, they are not adaptive whenever the environment changes. So the point is that they do not have a state element or memory to store the percept sequence and the actions that are being carried out. So whenever a new perception occurs, they find it difficult to work out. And the next type of agent is going to be model based agent, right? So model is like a knowledge base. It is knowledge about how things happen in the real world, right? So we have some, like human beings, we work on this model based reflex agent where we have knowledge about how things happen in the real world, and based on that we work, right? So since they have a state element, model based agents can work on even partially observable environment and track the situation. A model based agent has two components, right? So it has a model, which is a knowledge or repository of information about how things happen in the world, right? And it has an internal state, that which is a representation of the current state based on the percept history, right? So these are the two components of the model-based agent. It has a knowledge about how things happen in the real world, and it has an internal state to store the information about the current state based on the percept history. Right, and if you want to update a model-based agent, the agent state requires information about how the world evolves and how the agent's actions affect the world, right? So in the case of model-based agent, we have a state element to store the knowledge base about how things happen in the real world, and we have an internal state to store like how our actions affects the state of a particular system, right? And the next category of agent is going to be goal-based agent. So goal-based agents expand the capabilities of model-based agent that we have discussed by having the goal information, right? So we are going to add some component like goal information to a model-based agent. We call it as goal-based agent, right? So, what do you mean by a goal? Right, the goal is a desirable situation. The agent needs to know its goal, which describes the desirable situation or desirable performance metric that can be performed by an agent. So here, in the case of goal-based agent, the software agent is expected to perform a sequence of actions so that they can achieve the goal, right? So goal-based agents are extension of model-based agent by having a goal information. So it means that they have a knowledge base about how the world evolves. It has an internal state to store the percept history, whatever the information that has to be in percept from the environment, it's stored in the percept history. And finally, it has the goal information. So the agent needs to know the goal, which describes the desirable situation. And goal-based agent, they need to choose an action so that they can achieve the goal. So in the case of goal-based agent, the software agent has to consider a long sequence of possible actions before deciding whether the goal is reached or not. And since it's a goal-based agent, we do have a different scenario, right? So it involves searching algorithms, searching and planning for a goal, which makes an agent proactive, right? So goal-based agents are extension of knowledge-based agents. Like so, we are going to search and plan. So the agent has to search and plan so that it can achieve the goal. And in the case of goal-based agents, the agent has to consider a long sequence of possible actions before deciding whether a goal is reached or not, right? And the next type of agent, intelligent agent, is utility-based agents. So utility-based agents are again similar to goal-based agents. So they are similar to goal-based agents, but we are going to add an extra component of utility measurement, which makes them different by providing a measure of success of a given state, right? So we are going to add a component to utility-based agent to measure the success of our goal, right? So it's like reviewing a product, say whether it's going to be you have some 5-star rating for a particular product or a 4-star rating for a particular product, right? So goal-based agent is giving a desired product or service to the end customer. Whereas utility-based agent is like you are going to have different ratings for achieving the goal. So it measures the level of that a particular product or service has given happiness to the customer. So again, utility-based agents acts based not only on goals but also on the best way to achieve the goal. So in utility-based agents, I will try to look for the best possible way to achieve the goal. And utility-based agent is useful only when there are multiple ways to achieve a particular goal, and agent has to choose one of the alternative in order to perform the best action. Right. So whenever multiple solutions are possible and one has to choose the best optimal solution, we can go for utility-based agent. So utility-based agents, they are going to extend the goal-based agents, and they have an extra component called utility measurement, which measures the success rate of a given state. Right. So the utility function maps each state to a real number to check how efficiently each action achieves the goals. Right. So that's it. You can give the metrics, you can give how much you have achieved your goals using some 5-star rating. Right. So 5-star, 4-star, 3-star, you have different ratings for any product or service. Similarly, the utility function can map each state to a real number to check how efficiently each action achieves the goal. And finally, in intelligent agents, we have learning agent. So generally, any agent is likely to learn from its past environment, past experiences, or it should have some learning capabilities. A learning agent is expected to act with basic knowledge and then able to act and adapt automatically through learning. Right. So initially, when an agent is developed, it may have some basic knowledge about a particular system. Right. So once it is being deployed, it should be able to automatically learn from the environment. And learning agents should be able to learn from the environment. They should be able to analyze their performance, and they have to look for new ways to improve their performance. Right. So now most of the agents, intelligent agents, develop or of this type, learning agent. So it should will be building and deploying agent with some basic capabilities. The agent should be able to learn from the environment or from its past experience, and then it should be able to improve its performance based on learning. Then it's known as learning agent. Right. So for example, most of you have worked with chatbots. Right. So chatbot is a program. Right. It's like a question answering system that can answer any question, any answer based on the knowledge base that is available. Right. So while designing a chatbot, initially you may have some basic knowledge about a particular system. So the chatbot will be answering solutions based on only the data that is available in the repository. But over a period of time, on interacting with the customers, right, the chatbot will be able to know like what are the major requirements of the customer, and it can be able to give customized answer to different types of users who are interacting with the system. Right. So a learning agent should be able to learn from the past experience and it should be able to enhance its knowledge. Right. So initially, while deploying it, it may have some basic knowledge about a particular domain. It should be able to act. It should be able to do some perception from the environment, and it should be able to automatically update through learning. Right. And the thing in learning agent is that there should be some performance improvement before the learning and after the learning. Right. So initially, you are going to have a agent with a small knowledge base. In the case of learning agent, once it's exposed to an environment, it continuously updates the knowledge base, and over a period of time, it should be able to perform better than the basic version of the particular agent. Then we say that the agent has learned information from the environment. Right. So if you look into the learning element, the major components are going to be learning element, critic, performance element, and problem generator. Right. So learning element is responsible for making improvements by learning from environment. Right. So learning environment, we get some input. So the learning element will look into the environment, take some input, and it will make some improvement. And critic, it tells how the agent is doing, and it determines the how the performance should be modified to do better in the future. Right. So it's like a critic element is added so that it gives some feedback about how your agent is being performing and how the performance can be modified to do better. We have some performance elements which is responsible for selecting external actions. Right. So any system will have some performance metrics. Right. So based on the performance metrics, we need to improve the performance metrics like accuracy, precision, recall. Right. So for image recognition or classification. So what we do is that we have some performance metrics. So similarly, any learning agent, it has its own performance elements, and based on the learning, it is expected to improve the metrics like accuracy, precision, recall, and finally problem generator. So it is responsible for suggesting actions that will lead to new and informative experiences to the agent. Right. So by means of problem generator, it will generate some new problems, and it will give some new experiences, new and informative experiences to the agent. Right. So these are the four components of the learning agent. Right. So any learning agent, it should show improvement in performance over a period of time. So initially, while you are deploying a model or an agent, will be deploying the agent with some basic domain expertise, and the learning agent is expected to learn from the environment, and over a period of time, it should be able to enhance its performance based on its learning element. Right. So we should also have a critic in learning element, which gives some feedback how good learning element is progressing, and how good it is performing with respect to performance standards. Right. So a critic can give feedback about how good your learning agent is performing and how it's performing with respect to performance standard. And we have some performance element to evaluate the functionality of learning agents. And finally, problem generator, it is responsible for generating a new and informative experiences for the learning agent. Right. Next, we have this multi-agents. So it's a computerized system composed of multiple interacting intelligent agents. So the thing is that we have more than one interactive intelligent agent. As I said that these agents can be either competitive or they may be cooperative. So whenever you have multiple interactive agents, they can be competitive among one another or they may be cooperative in nature. So multiple agent systems can solve problems that are difficult or impossible for an individual agent or a monolithic system to solve. Since they are going to since we are going to have multiple agents, right? So they will be able to solve more complex problem, right? So in multi-agent environment, we can have competitive multi-agent environment in which many agents are working in parallel to to maximize the performance. We can also have cooperative multiple agent in which all the agents have single goal, right? So in the case of cooperative multi-agent, they have all the agents, all the intelligent agents, they have a single goal. Whereas in the case of competitive multi-agent environment, like the intelligent agents will work parallel to maximize the performance of their own individual. So we can include intelligence in multi-agent systems using functional procedural approaches or using algorithmic search or reinforcement learning. So in the case of reinforcement learning, it's like we reward if something is successful, we reward a person, right? If it's not successful, we give some penalty. If there's a failure, there's a penalty. Whereas if there is a success, there is a reward for each and every milestone that is being achieved. Thereby, the system will be able to improve itself, right? So basically, we have two types of multi-agent systems: competitive multi-agent systems and cooperative multi-agent systems. So, in the case of cooperative multi-agent systems, all the agents they work towards achieving a single goal to get high performance for all of them put together. Whereas in the case of competitive multi-agent environment, they work parallelly to improve their own performance. Right, like the game playing chess, it's a competitive multi-agent environment. Whereas trading can be a cooperative multi-agent environment. And the agents in a multi-agent system, they have some important characteristics like autonomy, local views, and decentralization. So autonomy means agents are independent of each other. The multi-agent environment, they are self-aware and they are autonomous. And local view means each and every agent, they can have local view about a particular domain, local view about a particular domain. So they do not have full global view of the system, which is too complex for an agent to exploit such knowledge. And decentralization. So decentralization means we are going to have some distributed systems so that things can be effectively controlled. So these are the advantages of multi-agent systems. And if we consider the steps in designing an agent, right? So whenever you want to design an intelligent agent, the steps to be considered are like you need to define the problem area in a complete manner. For example, I would like to develop a automated face recognition software or automated taxi driver, autonomous vehicles, or a simple chatbot, right? So the first step in designing a software agent is that we need to define the problem area. Once you define the problem area, you are expected to define and tabulate the PEAS. So performance, metrics, environment, actuators, and sensors, right? So define the problem area, define and tabulate the PEAS, performance, metrics, environment, actuators and sensors, and then you need to define or tabulate the agents functions, right? So agents functions are going to be the percept sequence and action columns, and then you are expected to define and design agent programs. So like a program is like a agent program is like a software model which is going to perform the agents functions, right? So once you define the agent program, you are going to implement the agent program on the architecture. You are going to implement the software on the hardware. So this is how we are expected to design an intelligent agent, right? So that's it from me. Questions from the participants? Right. So thank you for your participation.
Yes, thank you, professors. So the next link we will share in the WhatsApp group for the tomorrow session. So you don't worry about the attendance. Okay, we will collect the attendance from your Google Meet link. Okay, thank you.
Thank you, sir. So is the session over now?